You know, that immediate mental hurdle when you start thinking about an AI agent project, it's almost always complexity. Your mind just leaps to uh, perfect prompts, multi-agent setups, rock-solid security.
Right.
And these ideas, they're important down the line, sure, but they kill, what, 90% of projects before they even get off the ground?
It's total analysis paralysis. It feels like you should be thinking about that stuff like it's best practice. But the reality, the sort of liberating truth here, is that the 90% you actually need to build something that works, something you can ship. You can probably grasp that in like under an hour.
So, welcome to the deep dive. Our goal here is to guide you through what really matters with AI agents quickly without you getting lost in all the noise.
Yeah, we want to cut right through that perfectionism trap.
Isolate those practical, ship it today basics.
Exactly. So today, we're going to define the 4 core parts of any agent, lay out a simple 3-step launch sequence, and cover the essential lightweight ways to handle tools, security, and actually deploying this thing.
Okay, let's dive in and try to make this feel a bit less daunting. So segment 1 is this perfectionism trap. I think we've all felt this. You get an idea for an agent, and immediately you're picturing how, I don't know, Google or OpenAI would build it, this massive, intricate system.
And that's the moment, right? That's usually where the idea just stalls.
Yeah.
Because it's this engineering exercise for a scale you don't even have yet.
Yeah.
But the pattern for success, what we actually see working, it's developers starting really simple.
Shipping fast.
Shipping fast. And then iterating based on what real users are telling them, not based on some abstract theory of perfection.
So the core message is really resist that temptation. Focus on the practical 90%, just what you need to launch something basic that works. What do you think is the main psychological block there? What stops people shipping?
It's overcomplicating that foundation. That's what kills projects before they start. Simplicity, especially early on, that's actually a feature, not a bug.
Okay, so let's talk anatomy. Before touching any code, what are the absolute essential parts? You're saying there are just 4.
Just 4 core components, yeah.
Yeah.
Doesn't matter how fancy it gets later, these are the building blocks. First up, tools. Think of these as the agent's hands.
Okay.
Their functions, letting the agent, interact with the outside world, search the web, query a database, send an email.
Right. Without tools, it's just talking. It can't do anything.
Exactly. It's just a chatbot otherwise. Number 2, the large language model, the LLM. That's the brain.
Your GPT, Claude, Gemini.
Right. The reasoning engine, it looks at the user's request, looks at its instructions, and decides, okay, which tool do I need for this?
Then number 3 is the system prompt, the instruction manual.
Yeah, that's a good way to put it. It's the high-level programming. Defines the agent's personality. Is it helpful? Snarky? Sets its goals, its rules of engagement.
And the 4th piece is memory systems, the context.
Crucial. This covers short-term memory, basically, the current conversation history, and potentially long-term memory, like remembering user preferences from last week or important facts it learned.
And that's it. Everything else, deployment, monitoring, that's all just refinement.
It's refinement, not the core foundation. The LLM is the brain, sure, but which component actually lets it do things in the real world?
That has to be the tools. They're the hands, letting it interact with APIs, databases, whatever it needs.
Okay, so how do we actually launch this? The hello world for agents. It's just 3 steps.
Step 1.
Pick an LLM. For prototyping, just pick something cheap and fast. Don't agonize over it. Claude Haiku is great for this.
Okay, cheap and fast. Step 2.
Write a basic, clear system prompt. Just the essentials. You'll refine it later once you see how people actually use it.
And step 3.
Add 1 tool. For just one to start, maybe a simple web search, or even just a calculator.
And if you do those 3 things,
You have a working agent, it can take an instruction, reason about it, and perform an action. And honestly, this can be like less than 50 lines of code. It's really not complex to start.
okay, you mentioned setting up the LLM connection. You talked about OpenRouter. Why is that important early on?
Yeah, good question. OpenRouter basically gives you one API key that works for almost all the major LLMs, GPT, Claude Gemini, Mistral, you name it.
So switching is easy.
Super easy. You change like one line of text in your config file, and boom, you're using a different model. No vendor lock-in, easy testing. It's a smart move from day one.
You know, I have to admit, I still sometimes wrestle with the temptation to just let the LLM handle things like math.
Yeah.
Skip writing a calculator tool.
Oh, totally. It feels like it should be smart enough, right?
Yeah.
That's a classic trap. LLMs are fundamentally token prediction machines. They predict the next likely word, or token, that makes them surprisingly bad at precise arithmetic, like really bad sometimes. So adding a simple calculator tool isn't just a nice-to-have, it's often necessary. It compensates for a core limitation of the LLM itself. Why is adding a tool for something basic like arithmetic so crucial then?
Because LLMs are just inherently weak at precise math. They need tools to make up for that fundamental gap.
Okay, let's nail down some specifics. LLM choices. For prototyping, like I said, I really like Claude Haiku 4.5. It's super cheap, incredibly fast, great for just getting things working.
And then when you think about maybe moving towards production,
Claude Sonnet 4.5 seems to be hitting a sweet spot right now. Good balance of intelligence, speed, and cost. But again, the real point here is use something like OpenRouter.
right.
So switching between Haiku, Sonnet, maybe even GPT-4 is just changing that one line. Don't get locked in because of hype. Test what works for your use case.
Makes sense. And the system prompt, that instruction manual. You mentioned a template to avoid staring at a blank page.
Yeah, a simple 5-section template really helps structure your thinking.
What are the core sections?
First 3 are key to start. 1, persona and goals, just 2 or 3 sentences.
Yeah.
2, tool instructions, how and when to use the tools you've given it. 3, output format tone, how detailed should it be, that sort of thing.
And the other 2 sections, you said ignore them at first.
Right. Section 4 is for examples really only needed for complex, multi-step tool workflows. And Section 5 is miscellaneous instructions. This is like the fix-it section.
So why start with just the first 3 and ignore the others initially?
Because you should only fill in that miscellaneous section based on observed behavior. Let your agent mess up in testing. If it tries scheduling meetings at 3 a.m., then you add a rule. Never schedule meetings before 9 a.m. Use real feedback. Don't guess about edge cases up front. Start simple.
Okay, tool strategy. You mentioned a limit.
Yeah, a general rule of thumb is try to keep it under 10 tools per agent.
Yep.
Once you go beyond that, the LLM tends to get confused.
Yeah.
If the performance drops, it starts picking the wrong tool, it just gets overwhelmed.
Only 10. I've seen people build agents with like dozens of tiny little function calls. Why the limit?
It's really about the LLM's cognitive load and the context window. Every tool you add, you have to describe it in the prompt. That eats up precious token space.
Ah.
And the more tools it has to choose from, the more time and tokens it spends just deciding which one to use. Often incorrectly if there are too many similar options. Keep it focused.
And if you could only build out one core capability at first?
RJ, no question. Retrieval augmented generation.
That's giving the agent access to search private documents, right? Internal knowledge bases.
Exactly. And the data we're seeing suggests something like 80% or more of the real business value from agents comes from this capability. Letting it use your company's internal data, customer history, technical docs.
Master RRA first.
Master RAG, and you unlock the most valuable use cases right out of the gate.
Wow. Yeah, I can see that. Imagine just asking it to pull key risks from the last 1,000 customer contracts instantly.
Yeah.
That's huge for a business.
Totally transformative. Now, security. Don't panic, just basic hygiene. First rule. Never, ever hard code API keys in your code.
Use environment variables. Standard practice.
Standard practice. Then look at Guardrails AI. It's an open source Python tool. It lets you basically wrap your agent.
Wrap it. What does that do?
It gives you input protection. It can block things like prompt injection attacks or filter out PII, personally identifiable information like names, addresses.
Okay, so it cleans the input.
And it filters the output too. It can check for factual consistency, make sure the agent isn't leaking sensitive data. It's like a basic safety net, lets you ship things internally with a lot more confidence.
And you also mentioned SNCC for vulnerabilities.
Yeah, there are prepackaged tool collections, sometimes called MCP servers, that bundle security checks. Using something like SNCC can automate vulnerability detection during development. Just good practice.
Yeah.
So if you're focusing on just one tool capability for that first agent, what's the priority?
It's got to be ArcE. Because that ability to tap into private company data, that's where you'll find the most immediate business value.
Okay, last lap. Optimization and actually shipping this thing.
Yeah.
Cost is a big one. Context window costs.
Right. You pay per token, both input and output.
So keep your system prompts concise. Keep your tool descriptions tight. They get sent with every single call to the LLM. Don't be verbose there.
And for memory, for the conversation history.
You absolutely need that sliding window memory trick we talked about. Don't send the entire chat history back every time, especially if it's a long conversation.
Just the last, say, 10 or 20 messages.
Exactly. Use that simple list slicing, like conversation 10 in Python. It dramatically cuts down your token costs.
What about things the agent needs to remember long term? like user preferences or facts it learned weeks ago?
For that, you'd look at something like Mem0. It's an open source tool specifically for persistent memory. It uses AG principles itself to store facts sufficiently and only retrieve the relevant ones for the current query.
So it doesn't stuff the main context window with old info.
Right. Avoids those unnecessary token costs for stuff that's not immediately needed.
Then there's observability, seeing what's going on inside.
Yeah, you really need this for debugging and just understanding costs. Langfuse is a great, easy to integrate option. Gives you a dashboard,
What does it track?
tracks the whole execution flow step by step, shows you token usage per step, latency, which system prompt was used.
Yeah.
Invaluable when your agent does something weird and you need to figure out why.
And finally, deployment, getting it running.
Think Docker native right from the start.
Yeah.
Build your agent inside a Docker container. Makes it super portable.
Is it heavy? Does it need big servers?
That's the surprising part. AI agents are usually really lightweight. All the heavy computation, the LLM inference that happens on OpenAI's or Anthropic's servers.
Oh, okay.
Your code is mostly just managing API calls and maybe running a simple tool, so it can run on a small, cheap server. A Docker container, maybe with a basic web front end like Streamlit if it's chatbot,
Right.
or just a serverless function like AWS Lambda if it runs in the background. Keep it simple. So,
Token costs, they add up fast. What's the absolute simplest, most effective way to manage memory for a long chat? Use that sliding window. Send only the last 10 or 20 messages. That saves huge amounts on token costs compared to sending the full history every time.
okay, let's recap the big idea here, the 90-10 rule. What's the 90% that really matters? The stuff you should do now.
All right. Pick an LLM Haiku is great for testing. Write a basic system prompt, just those first 3 template sections.
Add 1 to 3 tools. Really focus on ARG for accessing internal data. That's usually the highest value starting point.
Add basic security with guardrails, AI input, and output protection. Add simple observability, something like Langfuse.
Control that short-term memory cost using the sliding window trick. And build it all with Docker in mind from day one. Easy deployment later.
And critically, what's the 10% you should actively ignore at the start?
Ignore the complex multi-agent systems. Ignore crafting 5,000-word perfect system prompts. Ignore Kubernetes orchestration for your first simple agent. Ignore building massive custom evaluation test suites before you even have user feedback.
Right, the agents that actually ship. They shipped because the builders resisted that urge to over-engineer everything up front.
Exactly. Focus on the foundations, get it out there, get real feedback, then iterate.
So the call to action is pretty clear. Find that 50-line code example mentioned in the source material, or just start fresh with those core components. Build something simple, like today.
Yeah, don't wait for it to be perfect. You don't fail by shipping something simple or slightly flawed. You fail by letting perfectionism stop you from learning. And you only really learn from real-world usage.
So a final thought to leave you with. What simple problem, maybe even an annoying little task you do every day, could your first basic agent solve right now? Outro music fades in.